Hello again and welcome. So recently there was a post up on EV blog titled Most Embarrassing Junior Tech Moments. So I thought for this video I'd tell you a couple of stupid things I did when I was first starting out as an engineer. So to give you some context, when I first started working in engineering, the IBM PC had just been introduced. From what I remember, these PCs cost about $2,400 or something at that time. Now in engineering, we were using the IBM PC for a lot more than just word processing. We were using these as a control system. So I designed and build my own hardware for these PCs to automate some of the testing that we did in production. So I had a task where I wanted to automate some equipment that was running off of the AC power. And of course, I turned to the IBM PC. So we purchased the PC brand new, and I bought some kind of a digital I/O board. I didn't build my own in this particular case, but I had designed a interface board that connected between that and my AC line powered stuff. And what ends up happening is I turned the thing on for the first time. I lit that PC up. I mean, smoke pours out of it. It was down for the count. So back in those days, the company that I worked for, if you exceeded, I think it was like $1,000, that had to be approved by the owner of the company. It wasn't a big company or anything, so they take that kind of serious. So again, this was early on in my career, so you're thinking, ooh, you know, I could lose my job over that little mistake right there. So I set out to fix the PC. And if you're old enough, you probably know what this is. This is the Computer Hardware Reference Library. You can see it was produced by IBM. This is the Technical Reference Manual. One of the things this contains is the source code for the BIOS. And for people like me, where I was actually creating my own hardware, this was indispensable. The other thing that this manual has is a full set of schematics. So using these schematics, I started going through that PC. At that time, those were all through-hole components, so get out the solder sucker, start yanking them. The place that I worked for, we used a lot of TTL components, so we had stock of those, so it really wasn't a big deal to pull the parts. Well, I got down to one component on here, and I don't remember which one it was, but what ends up happening is we don't have the part, and I've got to get this PC fixed. So I ended up making this part here, and you can see it's two TTL parts that are sandwiched together, and then they're hardwired down to a dip, and then I plugged this into the board to replace that blown part. And I was able to actually get the PC running, and nobody was the wiser. In the end, I don't even think I replaced that I/O board. So that's not the end of the story. Of course, time moves on, and I moved away from that company, and I really didn't think about that PC anymore. So many years later, a friend of mine is working out on the production floor of that company, and they're decommissioning this test fixture. Of course, that PC that I damaged had been reallocated, and it was actually still in service. And he goes to pull that PC apart, and he sees this IC. And he's like, what the heck? So he saves this thing, and he ends up presenting this to me, and he asks, you know, is this your work? And of course I had to tell him about what had happened, and we both had a pretty good laugh over that. So that was the first time I ever blew up an expensive piece of hardware. Actually, over the years, I think that that's probably the most expensive thing I ever damaged. So another quick story is early on in my career, we were working on a speech recognition system, and we were actually assembling this thing on breadboards. We had this tower of these 3M boards. These things were about maybe this big here. They had 4 individual whiteboards mounted to them, and they had the power inputs and stuff. And we had probably 8 of those set up on this big tower. It was just really a crazy setup. Unfortunately, back then we didn't have cameras, so we didn't take photos of it. So I don't have anything that I could show you that would explain just how messy this thing was. You could just imagine all these wires, what it took to do this recognition system with essentially dip components. We had some very good technicians working for us at the time, and those guys were very meticulous about routing the wires, so they looked actually quite clean, and we did get it working, which is a pretty good testament to those 3M boards. But anyway, so one of the things that we had to work on was the microphone input, and this was used in a fairly noisy environment, so we were doing noise cancellation. So we had these fairly expensive microphones. They were about I don't know, maybe a 1/2 inch diameter, fairly small, and those included the amplifier. So I had 2 of these things that I had to wire into the system, and for what I remember, they had a red, black, and white wire coming out of them. And of course, I was pretty young at the time, pretty cocky, thought I knew everything. So I wire the red to the plus, the black to the ground, and the white is the output signal. Turn the thing on. Oh, no signal. So then, of course, I turn to the data sheet and I realize that the red is actually the ground signal and the black is the positive. Of course, I wire it up the correct way, but it was too late. The microphones had already been damaged. I think the cost at that time was about $70 a microphone, and it set us back a few weeks. And of course, at that point, I was very humbled that I really didn't know much of anything and was pretty stupid. So I learned an important lesson, which was always read the data sheet. And of course, if you're a hardware designer, you know how daunting that task can be, because some of those data sheets can be hundreds of pages long. Well, those are my first 2 embarrassing stories. I think that's going to be it for this video. Hope you enjoyed the short clip, and we'll see you in the next video. Later.